Hello, everyone, and welcome to today's Tech Talk on Top 10 Commissioning Lessons Learned. My name is Sherry Adams, and I will be the moderator for today's session. Please note that throughout the Tech Talk, all the phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. We'll have questions, and if you have questions, we will be using the Q&A function. So just ask your questions in there. We'll be taking questions, and we'll have save time at the end for some Q&A. We will also be recording this Tech Talk, and it will be made available on our website under the resource section. Today's presentation is brought to you by the Northwest Chapter, and today's presenter is John Herbock. John is the Senior Commissioning Engineer at Affiliated Engineers, Inc. He started commissioning career in late 2007 at Northwest Engineering Services with nearly 15 years experience with a focus in fire life safety and building envelopes. He currently serves as the Northwest Chapter President of the Building Commissioning Association and believes that sharing project successes, failures, and best practices is a professional duty. So welcome, John.
Thank you. All right, I think we'll just get right into it. Yeah, let me click on this. All right, so this presentation, I'm going to go over some specific commissioning projects and lessons learned. They do apply to multiple projects, but I'm just going to use some project examples to go over some points about, both positive and negative outcomes from the design process through construction, performance testing, and commissioning practice in general, and all of our scope activities. I think the main thing I want you guys to learn from this is the takeaways of how you can identify some of these source issues and enact some preventative measures. I mean, the key to a lot of stuff is visibility of a problem to then start your problem solving process. Preventative measures, there's things you can try, but visibility and communication end up being one of the primary ways to prevent stuff. So I'm just going to dive in right to my first project example. This project is in Central Oregon, and just to give you a little setup on this is there was from beginning through construction and then the commissioning functional testing, a lack of team cohesive communication. And this was a remote site. So if it's in Central Oregon, I was based in Portland, Tigard. When you have remote projects, there is a huge need to establish that sort of team collaboration and the communication structure because it will bite you so hard. This project was for a performing arts center, and they had 2 really large air handlers and a nice mechanical room. You got some pretty ductwork, some lighting, and then you also had this building also had locker rooms for a field next door and or next to the building. And so you had the primary function for performing arts, but then you also had space and equipment for a different use. And one thing that happened on this project is that in the early sort of submittal process, this was before we had your Bluebeam review sessions set up where you can have what's it called? Concurrent design reviews and communication on submittals, that there was a big difference between what the design intent on some of this equipment was supposed to do and what was ordered and approved and what was installed. And so when we're out on our site visits, we're typically using approved submittals to check equipment. And there was one aspect that was missed on this heat recovery unit for the locker rooms. And that was that the designer ended up was expecting a return damper for recirculation in the building. And the equipment that was ordered did not have that. And so that was one problem out of many that showed up on this project and what led to a frozen coil. So when we did our inspections, you go out there and take a look, do your normal looking, is this equipment going to function right? Things look just fine. New piece of equipment, My assumption was that, that some of the difference between the design and the approved submittals was known by the lead mechanical engineer for the project. And that assumption, starts that process of, a potential gap or a miss. I didn't have regular communications with the mechanical engineer record, and the controls designer or the controls provider was throughout the installation process was doing a very poor job of keeping me up to date and or responding when I prompted them and the project team how install was going. And so there started to be a huge gap between what should be happening and what type of communication should be happening leading up to programming and functional testing. And so when let me keep it on this one. So I started, my ears started perking up, my hair started raising, on the back of my neck, because I was having a lack of participation, not only from the controls provider. And this was before I got into the habit of holding regular sort of CX coordination meetings. I'm trying to remember what year this project was in. I want to say 2014. So it's quite a while ago, before we had Teams meetings and Zoom meetings. And you had to have to drive to site to attend construction meetings. So I had lack of documentation from the controls provider on checkouts. I had them not responding to progress requests, both by phone and email. And so everything was leading to potentially a bad start time for functional testing. And still, though, apparently things were meeting schedule, I showed up on site and started functional testing this equipment, this whole building. And I was getting quite a bit of issues on this project, but nothing that seemed extreme. And that was leading up to, though, I ran into this heat recovery unit here, and I started noticing there was a big difference between what was in the control diagrams, what was programmed. And I typically, when I go functional test a piece of equipment, I go through the safeties first. All the statuses, the equipments, but I go through, smoke shutdowns, duct detectors, I do freeze stats. I go through and check safeties when any equipment is going to be operating or continually operating. And that's the first thing I typically go after, because I want to make sure that, that it shuts down properly on a high static or low static. I want to make sure equipment can't be damaged when we test equipment. So that's the first thing I go through, and I noticed that there was no freeze stat, hardwired freeze stat on 2 downstream heating coils that were in the space. And I'm glad, the heating coils were in the space and not up in the unit. Typically anything east of the cascades, I always say, don't have hot water coils in a roof if you can avoid it. And they had it out of space. I'm like, that's great, but there was no hardwired freeze stats. So I brought that up. They had a software freeze stat, and I tested that, and it wasn't working. It didn't shut down the unit. So I started calling up the controls provider, and he wasn't responding. I put it on the issues list. It sat there for a week or two. And then I saw in the forecast that we had cold weather approaching. So I reached out again, no responses, multiple times, called his office, and find out that he's on vacation. Uh-oh, I have a cold front coming in. Freeze stat safety is not working, and the controls provider can't be reached. So, more red flags just throwing up there. And when I called his office, they ended up saying that no one was assigned to it be a backup for his project, and they didn't have anybody they could transfer me to address my issues. And I made one mistake, and that was I didn't then follow up with the rest of the team. I think it was late on a Friday. And I should have probably tried harder to reach the project team to make sure that equipment wasn't operating. I assumed that the schedule was supposed to be shut down on the weekends, and I think it was. But lo and behold, we had, it takes more than one thing to freeze a coil. It takes the equipment operating, it takes a safety knot working, and there has to be a series of events for something bad to happen. We showed up, I get a call Monday morning and they reported frozen coil. They had water damage everywhere. And, I started, besides cursing a lot, we started pulling up how did this happen? So we started doing failure analysis immediately. And this is the trend that I pulled up to share with the team for the meeting. I think we had a meeting the next day, and we show the discharge air temp dropped significantly down, and we're like, why? Why is all of a sudden did we lose a safe operating condition to a non-safe condition and a frozen coil? Well, if you look at here, bottom left, the exhaust fan's VFD status says on, but and it stays off when the supply fan turns on. Oh, the exhaust fan failed. So there was some sort of thermal relay that it overheated. And when you have a heat recovery unit with a heat wheel and your exhaust fan stops working, guess what? You don't transfer any of that building heat to that incoming cold outside air, and your supply air temperature drops. With the software freeze stat not working and shutting down the unit, now you have cold air coming over coil. And then I'm pretty sure it was early in the morning and the heating water system wasn't hot enough or there wasn't enough demand, or there wasn't hot enough water to keep those coils from freezing up. So big, huge lesson learned there, ends up being, when you start realizing there could be a problem, how far up the ladder do you communicate to the team? You want to get it visible to everybody, and you want to get it high enough that the right people see it and understand the type of problem. But even then, it can fall on deaf ears if people aren't paying attention, or somebody goes on vacation and you can't get action by a team after you've made it visible. So here's a little screen graphic. This was another sort of little red flag to me when I do functional testing, and that is that this equipment doesn't match how it's orientated in the field. So that's definitely something I do now automatically when I show up on site. I start seeing, or before, if I get remote access, if I start seeing their graphics more like boilerplate and not matching how the field equipment is orientated, whether it's the fan location, where the coil is located, where the sensor is located, I hone in that really fast, and I try to make sure that gets changed quickly, because a lot of times when programmers are doing work, and you don't have somebody super experienced, or they don't know how all the field equipment is done, you have a programmer versus the field installer, for a controls team, that there can be a disconnect on how that equipment is to operate. Because you look at a graphic, and especially on safeties, and you think, maybe the temp sensor is in the wrong location. That might impact how a safety operates. That might impact how equipment performs. And it really does make a huge difference. So after this problem showed up, I got them to change the graphic to match what the field actually shows. And then they ended up installing a bypass damper and adding that functionality to keep that circulation going during morning warm up. Because I think that's what ended up, if I recall correctly, the morning warm up during that phase, that's when the coil froze. Just things weren't heated up. It started early. The heating water system wasn't operating the whole weekend like you'd normally do in a freeze condition outside, and on top of the equipment failure and component failure. So, the communication and the importance of directly going over, how the equipment's supposed to intend, or how it's intended to operate, some of the selection components, having that type of discussion or understanding for a project is key between parties. And, you can usually don't have to, sit in with a mechanical engineer and the controls provider, on every project. But there is value there, and directly from that value comes efficiency on how you test equipment. That interaction with that controls provider ends up being so valuable, and same with that relationship with the engineering team ends up being so valuable, not only on that project, but on future projects. To recognize those red flags and act on them are two different things. It ends up being your responsibility to, if you notice something, to make that issue known and visible. You're not trying to, what's the term? Sort of like, cry wolf type situation. You want it to be visible, but you don't want to be alarmist. That's what it is. You don't want to be an alarmist unless you know that there is a situation that requires that type of action. You want to be the problem solver, less the problem notifier. So make that extra step to both recognize a potential problem is brewing and then try to alleviate that. Talk with the leadership on a project. Hopefully you have a strong GC or with the engineering team. They will thank you eventually, maybe not in the short term. If you bring those type of problems and experience to the table, it is invaluable to bringing value to a project, that you can bring those type of issues to the team in a collaborative or problem solving mode rather than an alarmist mode. And in this situation, I ended up having to do a huge sort of communication log on how often where we got to the point for this failure. So, phone calls are great, and having a phone log is great, but I end up typically now writing notes down on, depending on the project, what some of those calls were for, whether it's in my timesheet or whether it's somewhere else, or a note log or something like that, because it ends up being valuable on a post-mortem situation, analysis situation. And then another thing was that the teams that share failures make stronger bonds than project successes. I use this example, and I have relationships with team members on that project that have lasted so much more than some of the projects where everything went okay. So understand that project failures can be tools as well, both on a learning basis, on a relationship building basis, and failures, don't just have to be bad. And I sort of use that as a life practice as well. This next project I'm going to hop right into is, let's see, a net zero project. Well, it had a net zero goal. I don't think it was really close to making it. Passive and active natural ventilation. You might run into these projects, whether it's net zero or a school. Typically, I see a lot of these where they try to use natural ventilation to the advantage of the classroom environment, whether that's the K through 12 or higher ed. In this project specifically, we had floor level space dampers, radiant slab, wind-driven and powered ventilators at the roof level, and heat recovery units that supplied the classrooms were disabled when natural ventilation was in use. And then, it was supposed to be able to do slab cooling as well, but I'll get more to that later. And they had an electric heat pump chiller, a modular heat pump chiller, and they also had a lot of the solar and day lighting in this project. And just to get into a little bit of the drawings, you had both ducted and non-ducted areas, ducted to these shafts, and then or ducted all the way up to the top roof. and then double opposed blade dampers at the floor level to try to prevent infiltration, unintended infiltration, and then a lot of user controls to put occupant comfort in the control of the occupant as much as possible, as well as disabling it if it wasn't working for them or wasn't comfortable. Another aspect, another remote site. This might come up often for you. Remote sites take a lot more effort and thought. This was a remote site for the O&M team, as well as for students. This was, I think, was out outside the Portland metro area. I think it's about a 40-minute drive. And it also had a lot of new equipment systems that weren't being monitored by the facilities team. And I think that was also an aspect of somebody was put in charge of this site, but didn't have the time or maybe it was the interest, but it might have been a combination of both, where the facilities team didn't treat this building as a priority, and it was a net zero building and required a lot more interaction with the facilities team. And if they don't have the time, that can be a problem as well. And there was equipment sizing and function was focused on efficiency as well as usability, but there might have been some areas where we ran into problems on there, and the accessibility of the roof was difficult at the site, which also can impact how the facility is maintained. So they started, we didn't do the initial commissioning on this project. We were actually brought in to recommission this building. After there was numerous occupant complaints, we had unintended drafts reported by users, cold drafts, I mean, we're talking, 55 degrees or 50 to 55 degrees at your legs when you're in a classroom is extremely uncomfortable, just like 55 degrees dropping on the back of your neck is uncomfortable. Way worse winter conditions with infiltration being even colder. Ceiling fans and ventilation was not enough on the hot days. This was a sizing issue. All these heat recovery units didn't have the capacity to keep up, especially on the sun-laden side, with the hot days. And this site was used, through May, I think maybe even early June. And I think they even had reduced summer occupancy as well. And it just wasn't useful. They were getting way too hot. And one of the problems there was slab cooling that was designed was never fully functionally tested and then never implemented. So I don't know if it was just a combination. They had some initial dew point stuff in their programming in there, but when I went through the commissioning documentation and looked at their functional test records were poor. It looked like they did sampling method on a net zero building, which I definitely recommend staying away from sampling method on a high performance building. And they never tested slab cooling, and therefore it was never used. No one had confidence it could work, even though it was programmed. So you're just seeing red flags all across the board, and that's why we were brought in. I think this was also there was a second part to this project that I was involved in, and that was some moisture problems in the roof. So we started taking a look at the design and construction of the dampers. As you see in this picture here, we have double sets of dampers controlled by one actuator. First of all, they were encased dampers with access, pretty poor with these screws and lock nuts that didn't really connect very well, pretty low quality on the casing connectors. And so it was a pain to get stuff off and back on correctly. And the linkages, because they were double sets of dampers with one actuator for them, the linkages allowed for a lot of play. Not the first one, you already have your standard, but the second one is magnified. So this was a quick identification on the problem for why unintended intrusion was happening, even though you had double sets of dampers stacked on in front of each other and behind each other. So that was an obvious issue that had to be rectified to just stop infiltration. And if you look closely, you don't even see gaskets on these dampers. And so there was a problem there with the quality of the damper sets on top of the double sets next to each other using one actuator. So ended up fixing this by doing individual damper sets, higher quality leakage class, higher torque, and making sure that we set the close position correctly with just a little torque at the very end, or additional torque to close it. So it's just a matter of setting that damper end stop to have a little bit of pressure, but not too much to hurt the longevity of the actuator. Additional insulation, we found poor sealing and missing insulation around some of these damper sets. So they used rigid foam, as well as, and tried to stay away from any of the spray foam, so that stuff could be removed and replaced if necessary. And then we also did a lot of controls revisions on this project. Damper position staging, prolonged passive ventilation period, so that you would use natural convection. And that was both an energy thing and trying to prevent large drafts into the building. And then narrowed the operational range of when these dampers can operate based on outside air temperature, so that we didn't have 55-degree air coming across people's legs, even if they needed the cooling. But, and then we functionally tested the slab, vetted the slab out cooling for slab cooling. And because it was a few years after it was built, weather forecasting programming was becoming available, as well as that data that you need to do that type of programming online through pulling in that type of information. So we instituted a weather forecasting program, as well as an automatic switchover based on, say, you have 3 really hot days upcoming, that you would get over a day in advance, you would switch from slab heating or a neutral slab to a cooling slab in preparation for hot days. So ends up taking a lot of fine tuning on it, but ends up being very, very worthwhile. If anybody has any projects that involve slab cooling and want some recommendations there, just let me know, because that weather forecasting switchover when you use the slab for both heating and cooling takes some additional work. How am I doing on time? Let's see, 11:30. Keep rolling. Ends up CX failures, lessons learned. Accessibility, usability is just so key to long-term maintenance and performance building. We all say this, we all know this. I always use the mantra when I'm on a site, well, maybe not mantra, language with project teams. It's like, I'm tall and skinny. If I can't get to equipment, no one's getting to equipment. If no one can get to equipment, how do you expect the facilities team to maintain this, change out filters? And stress that both in design, when you're out in the field using pictures, like, I can't get to this, this is not acceptable. Don't accept equipment that can't be accessed, because then it won't be maintained. High performance projects require a lot more extra scrutiny, more planning and effort. So, get people on board, and that's why that collaboration with both the designer and the controls team and the project team is really important. Even though we were brought in, post project to recommission this. Function, occupant comfort, and energy use can be balanced, but that takes even more effort. And that doesn't sound abnormal, but try to leverage your experience, the project team's experience on high performance projects, because there's so many things that can really change the direction and the energy use of a building when you're trying to be a high performing building. And if it's not designed with occupant comfort in focus, or energy use, trying to focus on that balance between function and energy use, your net zero project is never going to get there. All right, I'm going to jump right into project 3. There's actually 2 projects with this one. Another big thing for me with my building envelope testing experience ends up being really the value of mock-up testing and field testing. And when you're a commissioning provider on a project and you don't have that experience, there's some things that you can do to help the project team as well as the individual testing agency make sure that they're set up for success. And the mock-ups really got to match the field. And where it doesn't match the field, say like there's a concrete column that they're not going to replace and duplicate in the mock-up, that you understand how that impacts how the test is going to be performed. I've flown out to Montana to do testing and show up, I asked for pictures of the build to make sure that I could start reviewing that. I got pictures, but they didn't show enough clarity on a few things. And you can just waste a whole day of mock-up testing or field testing if the prep work isn't done, or something doesn't on the mock-up, if it doesn't match the field, the usability of that test and the application of the test can get undermined. So make sure that the test methods have a clear pass-fail criteria. You don't want to be deciding that when you're right on site and trying to get on call with the manufacturer and the owner rep and stuff like that. Test setup is really important. Substitutions and that compatibility, like I was talking about, is huge. Equipment accuracy of the test agency is really important as well. This project specifically, they were using fans that just can't dial down low enough. And so when you have that, your accuracy was out of range for the pass fail, even though it was a 2-story, almost 3-story mock-up. And make sure that in each test report that they include all the information that you can make either for a repeatable test and that you could actually hand calc out those results. Don't let it slip. If a report comes, a 1-page report comes your way and you can't even do a hand calc on something. So bring it up. Let's get some of that stuff improved. If you have any questions there, I'll come back and talk more on that. Envelope projects specifically, even if you don't have building envelope commissioning experience or even that scope, you as a CX agent, depending on your timing on a site, can still provide value. This is something that you're just going to have to learn as well, or have an interest to learn. And it ends up coming down to a lot of the detail work on these projects, because you have to understand the 2D and how that's going to impact the 3D in the field. Because flat surfaces, really easy to test, really easy to perform well. It's when you get into the 3D that overlapping air and water barriers and ends up being the biggest problem. When you're on a site doing building envelope commissioning, project orientation, photographic documentation, details, and taking photo series that show you where you're starting, where you're stopping, and where you're at end up being really important. You might not have, on this project that I'm showing here, I did not have a huge amount of envelope testing experience at the time, but I was able to help the building envelope consultant and the project team by providing the level of documentation when I was on site that could be used and reviewed. So I ended up collaborating with the building envelope consultant and the project team to try to make sure that we documented some of those areas before they got covered up. Because one aspect that you find when you do building envelope projects, that the exterior goes through so fast. The pace of installation is so fast, especially in this picture as a unitized glazing system. And that day they might do a whole column to column section, and like if you can't catch it, if you don't catch it when it happens, no one's ever going to catch it. So if you want to get started in building envelope commissioning, or you're already doing it now, you can provide value if you have very little experience, or you can provide an extreme amount of value if you have more experience, because recognizing when there could be a problem, you need to be able to bring that to the forefront really quickly. Otherwise, there's no path to go back besides the most expensive, which is pulling everything down. here is one aspect that you can do with no experience. Looking at how product is stored, whether it's mechanical, whether it's envelope in this case, really making sure that it's protected. We've always looked at ductwork with ends, covered, making sure there's not dust, you're not installing dirty ductwork, or it's on pallets so it's not sitting in water. Those are some of the intro to CX, stuff that you can pick up on a site visit. When it comes to the more complicated stuff, storing stuff outside, in this case, we had, these are pictures, aren't mine, by the way. These came from RWDI. We had all these unitized glazing systems, and they were stored horizontally. And, that was a problem in itself, because when it wasn't covered, or when it was being moved to the staging area, all of the fastener holes, sort of the construction manufacturing process, there are holes that allow air to travel between all the unitized, the glazing components for equilibrium, movement of air, pressurization type stuff inside a closed system, basically. And when you're stored it sideways, they were filling up with water. And I'll show a picture after this that will show what was found. Also, once you come to staging, they brought stuff up, and this was another place where water was allowed to get into them, if they were staged the day before. And then we started seeing rips in the insulation. So you can inspect stuff when it's stored in its main area, and then when it's staged in the field, there's another opportunity for stuff to get damaged. And this was a situation where both were true. And then this was also spotted by RWDI at the time. They were on site, and I think I was on site the day before, or a few days before. And also, it was a dry day, but there was wet marks all over the scaffolding. And the scaffolding was 3 or 4 stories up for the deck. And they're like, where is this water coming from? And, there's a question mark going on in your brain. And it wasn't until they looked up and saw some of these panels being swung into place that they saw the problem. And you wouldn't have known that some of these this glass had water in it until you saw this water everywhere, because it sort of hides inside these channels. But they looked up, and there was water dripping from the unitized glazing components and these panels. And what was funny is that they asked the installers at the time, what's up and everything, and obviously in a collaborative method. And the guy's like, they have water in them, but we know how to fix this. So we just swing it outside, drain it all, and then we install it. And great idea to get the majority of the water out. And looks like they got 99% of it, but in reality they didn't. And that's because the weep hole location, you can't get all the water out of the hole unless there was the low point, and the low point was maybe a ½ inch up the hole for it. And so you have, not only do you have water vapor inside, but now you actually have a water quantity amount, liquid water, and then they install it in a unitized glazing system. Installing products with water in them is a bad idea. I don't know how basic that comes across, but if you install products, unless there is a route to dry, and a reasonable condition to dry it with that route, you're going to have a problem. This was a unitized glazing system, and all of a sudden you have water trapped on a facade on a major building that's visible and it spelled so much problem. There was another aspect to this, and that was, we brought this was brought to the attention of the project team, but it was a hill that wasn't worth dying on. The project team, because of the pace of installation and the cost to go back, they weren't willing to do remediation efforts, actively. They tried their best as possible to track the potential risk, but it was one of those situations where this ends up being, a lesson learned here. And you need to understand that everybody wants to be whole in the end, but the project, actually, I'll save this for a question. The project team owns responsibility until they turn over the project. So your job as a CX authority, as a building envelope commissioning consultant, whatever position that you're in, you don't hold the risk. The project team holds the risk, specifically the general contractor, until it's turned over. And so what your job is in that area is to help them assess that risk, provide, what type of corrective actions paths there are, but you can't be the driver on that. Otherwise, you're not only not going to make any friends, you're going to be ostracized. Project specifications and detail review are really important on any of these envelope projects. And the level of detail really needs to be there. The simplicity needs to be there for the level of the installing contractor's experience. In this picture here, this is up on the hill here in Portland. This project actually had the manufacturer reps come out to site to help train and make sure they got started right. You won't get that for every project, but this team made use of that. It really comes down, if you're out in Montana, for example, you end up being a teacher for a lot of these installing teams because they don't understand what aspects in the construction will have an impact on performance until they're shown what fails. Your site visit quantity and frequency needs to be a lot higher because of how fast the pace of installation is, and your ability that will directly impact your ability to capture a potential issue. And if you can't be on site, then the architects team needs to be on there, or the GC needs to be helping document, say, like a corner before it gets covered up, and needs to transmit those photos like that same day so that they can be reviewed. There is a way to collaborate on that type of stuff, and with our document sharing sites these days, it has become much easier. And lastly, that mock-up and field performance testing timing and scope is so critical, because not only can you test something initially, say on the first floor, and stop a practice that will cause multi-floor failure or something that can't be stopped. Getting testing done both on a mock-up with real field sort of setup as close as possible is so important. And then, making sure that mistakes aren't repeated. And then that final performance test is sort of more of a validation. You're not going to find a fixable problem, most likely. Wow, I burned right through that. 11:45. How are we doing, Sherry?
I don't see any questions, but it looks like you probably just have a couple more slides, right?
I do. This last lesson learned was what I talked about earlier, like who carries that responsibility to evaluate the installation risk for envelope components and assemblies. What I said was that you're responsible to help them with the risk, but the assessment and their own internal for fixing it is their responsibility. So you're there to help them evaluate that risk, but they're the ones that hold that risk. And if no one wants to fix something, then don't go die on that hill. So with that, questions. Tried to cover 3 projects pretty darn fast.
Well, I'll make a quick announcement. That way, if anybody does have any questions, just as a reminder, you could pop it into the Q&A section. But just want to remind everybody that our annual conference is coming up on September 21st through the 23rd at Glendale, Arizona. Registration is open, and you want to keep a lookout for your emails announcing all the events that are going to be happening around that, like our Scholarship Foundation golf tournament, axe throwing tournament, and of course our annual dinner. So be watching for your emails for those announcements coming up. And let's see, anything, John, maybe you were just so thorough, we don't have any questions at the moment.
That's just not true.
There's something that just came up. Something just came up. Do you see that? Or
Yes, I see it. So, so when it comes to that freeze damage on that RTU for that Performing Arts Center, it was turned on and it was operational, and they were actually having training that either Monday or Tuesday when they actually it was Monday. So we all sort of just stepped into training knowing that there was a frozen coil, and that was a fun situation to meet the controls contractor that was on vacation. And we had gone through and done our initial testing, but corrections weren't done at the time. So that's the point where it was turned on, operating, and but it was the corrections weren't done. So I had issues, noting FreeStat wasn't functioning, and there was a failure to respond by the controls contractor, and also my failure to really hammer with the GC and collaborate with the GC to make sure that we got a response. So I tried getting responses on my own, and that is a lesson learned for me, there's one aspect to do it by yourself and to pursue and try to identify these red flag issues and whether or not it's a problem or not, but then to communicate that to the project team and make sure that it's visible to everybody so that you can get assistance from the GC or the owner rep to really get a better response than, oh, well, no one's responsible. No one was assigned to this as backup. You'll just have to talk to them next Monday. So that's a lesson learned for me. Let's see.
Oh yeah, so John, I was just going to say there are some more questions rolling in.
I see that.
Just as a reminder to read the question so that people will know what the question is before you answer it.
All right. Gert was that one of the first things we do is kind of point to point to make sure, among other things, that outside air dampers are really, really closed at 0%. And since they very often aren't, controls contractors then that hook up to BLEMOs don't seem to understand that closed or energy efficiency or comfort can be impacted by that. Yeah, I couldn't agree more. Making sure that things closed 100% is something I do as well. And when we do recommissioning efforts, that we recheck that type of stuff, because over time that can loosen up as well on the linkages. So yeah, is definitely a focus of mine after that point. I'll go to the next one from Dave. Are you an advocate on energy recovery unit that the heating and cooling coils on the main unit it serves are sized for no energy recovery? I am actually an advocate for backup heating and cooling. Maybe, so if you're not going to size the unit to be able to do full heating and cooling, and you are reliant on, some other equipment or conditions, my energy recovery units, especially if you're east of the Cascades in a place where it's more freeze prone, having backup heating capabilities, or having equipment operate in a fail-safe operation. So you have a cold front coming in that at 38 degrees, that the heating water system is running 24/7. So if you have a unit that's not sized or has to work compatible with another piece of equipment or program, that you need to have that sort of fail-safe condition, or you need to be able to have, for example, backup gas heat or backup or sized electrical preheat coil that could, in the worst case, operate to save your bacon, or your coil. If Dave has anything else, just let me know. I'll go on to the next one from Carrie. What code do you use for installation for access and maintenance is meant? In San Francisco, our city inspectors always reference NFPA. So when I look at drawings to say, and I look at the location for access, and depending on the project, they might even have a lot more information on ceiling height and stuff like that. I'm always thinking about access to equipment. There's no code for access other than say like NFPA for say dampers, that you need to have a one, at minimum 1 square foot of an sized access hatch or removable duct. All these components have to be accessed. So their location, whether it's in a classroom, in a maintenance corridor, from the hallway, try to just use your experience or try to advocate using function when you're reviewing or communicating with the project team. And then when I'm out on the site visit, I take pictures of showing people that how hard it is to access something, and then it gets fixed as easily or as much as it can. And so one thing that you're always going to try to consider, say like a damper set below an exhaust fan, because with most code now, you have to have an actuated damper below exhaust fans, any penetration that's used for HVAC, and you end up needing to put a hinged exhaust fan up on the roof so they can easily get to the damper set, because a lot of times down below, it's almost impossible to get to that actuator or that damper set because their ceilings might be pretty tall above the drop-in. So there's no code to reference that I use. I just use project examples for the most part, or pictures of me in the field. Next up from Mike, what are your thoughts on the quality of contractor training and any lessons learned from poor training? Well, if you want to talk about installing contractors or maintenance teams, there's all these different associations that certify, like ABA, or they might have renamed themselves, FGIA now, that make sure you have certified contractors for installing envelope components. It probably is true for other MEP systems, but we live in a day right now where you can list, contractor training requirements, but it ends up being who's available and who gets assigned to it that starts on a project and who actually does the work in the field. You have to be willing, if you have the experience, be willing to always train somebody in the field. So Mike, your question is sort of open-ended a little bit. If you have something specific, let me know. But lessons learned from me ends up being is look at the team you have at the start of a project, then look at the team of contractors that you have in the field and see if that ever produces a red flag in your mind for the site, the project, the location, and bring that up to the project team because maybe that's an aspect where people need to pay a little bit more scrutiny to if you find that the contracting team doesn't have the adequate training, or there's some additional training that is going to be needed. So let me know if you got more on that, Mike. Last from Anthony, code we use manufacturers installation requirements. Yeah, I mean, almost all of them say, that the installing contractor has to have this type of experience, this certification through this society or this professional organization. But there's a big difference between the manufacturer's installation requirements and what actually happens in the field sometimes. Taking a look at what the manufacturers require, whether it's temperature, on-site conditions, contractor experience requirements, just know what's supposed to be happening. And you maybe, like Anthony might say, is that you might bring that up to the project team. Don't know what more you want on that. It's not really a question, it's more of a response. But yeah, I'm on enough remote sites where until people see what type of problems can happen from inexperience or from a lack of knowledge on how stuff gets tested and how stuff fails, you can have all the specifications you want, but in practicality, teaching in the field is just what ends up happening.
Well, thank you, John. I think that's all the questions. We really appreciate your time and expertise today. And on behalf of the BCA, we'd like to thank everyone for participating in today's Tech Talk. Have a great day.
Thanks, everyone. And obviously, I'm always learning too. So feel free to chat with me. I'm going to try to attend the national or international conference. And I love chatting about this stuff. So give me a call, send me an email, whatever, meet me in person. There's just so much, and it's always changing out there, both in the commissioning and building envelope commissioning world.
Great.
Thanks everyone.
Bye-bye.